Welcome back to our study on counting to calculus. We are going through our book, Understanding Mathematics from Counting to Calculus by Keith Cresson, and we are going to be talking about numbers today. If you would like to order a copy of this book, please go to our website, amosthemathguy.com. You can fill in your information and I'll get it, or you can order the book on our Amazon page, which you can find in the description section. My email is amosthemathguy@gmail.com, amosthemathguy@gmail.com, and I am on a quest to help everyone learn math well. I want everyone to master mathematics. And so if you want videos on math history and math applications and math excellence and fluency, visit my website, subscribe to this channel. You can always look at our tutoring options as well as our online courses in algebra, pre-algebra, everything math, we have it for you. So reach out to amosthemathguy@gmail.com. We also have chemistry and physics for you. So reach out to us if you have any questions on that. The definition of a number. You already know in many ways where, the applications of numbers. We use it in sports, we use it in taking phone numbers down. And so a number is a symbol used to represent a collection of things. These symbols obey certain rules when they are combined with each other to make new symbols. The theory that explains the rules of combining these symbols is called mathematics. Another mathematician that actually talked about this very thing is Leonhard Euler. Leonhard Euler wrote a book called The Elements of Algebra. And remember, Leonhard Euler is like the Michael Jordan of math. He's like the greatest mathematician. Euler, Newton, Gauss. Those three names will come up a lot. Euler, though, when it comes to the amount of work he published in math, he takes the cake. And the fact that he became a blind mathematician later in life and still published 50 papers a year, I think he takes the trophy for that. So numbers are a key part of mathematics, but mathematics goes beyond just numbers. There's principles in math you're going to learn that don't have numbers, but it's the logical explanations that mathematics presents. Something to keep in mind, because when you start seeing letters, I don't want you to think math is strange. So we know what numbers are. We see them in different sports. And one of the first things in mathematics is knowing how to count. So we need to know how to count starting from natural numbers. The first natural number is 1. And I have a whole video on this, which you can find in the description section, or you can email amosthemathguy@gmail.com if you want me to just send you that video, or you can find the video just under classification of real numbers. So numbers, we have natural numbers. Natural numbers are numbers like your age, 1, 2, 3, 4, 5, all the way to infinity. Whole numbers include all natural numbers and the number 0. So if you have a notebook, I want to encourage you to write down natural numbers start from 1 and go to infinity. Whole numbers go from 0 and go till infinity. Then we have integers. That's negative numbers and positive numbers. Those are called integers. And then we have rational numbers. Any number that can be written as a fraction. So we have natural numbers, whole numbers, integers, rational numbers. Now we have a different kind of numbers, categorization called irrational numbers. That's where pi comes in. The digits of pi don't repeat in a regular pattern that you and I would be able to look at and say, this is repeating here. It's not like 0.333 repeating. Pi is 3.14 on and on and on and on, right? To billions of digits that we've seen, and people are going on, and some people have memorized them to many digits. Good for them. I wouldn't be doing that to a billion digits, but I think there's other things, but well done to those who have memorized pi to long digits. And so counting, when we talk about counting, we need to understand the different kinds of number systems, or the different kinds of numbers. Just think of that when you think of math. That's the very beginning. Now, in our book, it talks about different types of numbers. It gives you examples of numbers, and then it talks about one digit, such as 1, 2, 3, 4, 5. That would be one digit numbers. And then 2-digit numbers would be like 10, 25, 36. 3-digit numbers would be like 125. But when we start talking about these different types of digits, we have to bring in place value. So it makes sense to have some sort of quantity. So if you talk about place value, so for example, when we say 25, the 5 is in the ones place and the 2 is in the tens place. Place value matters. And so that's the beginning. We have counting and we have place value. That's the very foundation of mathematics as we move forward. Now, there is decimals, there's whole numbers, and there's decimals. And in our book, Tools for Master Mathematics, which you have access to in our course, Tools for Master Mathematics shows you the place value for whole numbers, and it also shows you the place value for decimals. These are very important to have in your notebook. Now, keep in mind that the journey of this book, or the journey this book provides you with, is that it provides you with a track record of something you can go back to review. So when you get this resource, you have it literally till you retire. So keep that in mind. So we have place value for whole numbers and place value for decimals. The next important concept in mathematics is understanding how to compare two numbers. So if I say 25 and 36, do we know which one is bigger and which one is less, which one is greater? Comparisons are important in mathematics. And part of why math is important, one of the applications of mathematics comes into play when you think of economics. Because the reality is there's not enough of everything to the point where we don't have to care that we're budgeting for it. Do you see? If you had an unlimited amount of money, you wouldn't need math, because you can buy everything you want, whenever you want, however much you want of it, because you have all the money in the world. But because we don't have an infinite amount of money, one of the applications of mathematics is budgeting. It's used in economics, which is a great field of study to keep in mind. And so we need to know how to compare numbers. Do I have enough to buy something? That's math right there. We do math every day. Math is everywhere. And so mathematics is the science of quantity, but mathematics also helps us to learn how to make sense of scarcity, or the lack of not having enough, and making sense of what you have in, to take care of your unlimited wants, quote unquote. And so here's how Leonard Euler says: math in general is the science of quantity, or the science which investigates the means of measuring quantity. Mathematics is the science of quantity. So we need to know the less than, greater than, addition, subtraction, multiplication, and division. We need to know all those symbols. And most times in your elementary school years, you learn those symbols. That is the first lesson in our Counting to Calculus series, is understanding counting, place value, numbers, comparisons. Now we can turn to our workbook and work through some of those practice problems. Thank you for watching this video. Please feel free to subscribe, like, and share, and encourage your friends to join you on this quest of counting to calculus. Why? Because math is beautiful and gettable. So we want everyone to master the principles, because once they get to calculus, there's no limits to what they can do with their lives. Reach out to amosthemathguy@gmail.com if you need any tutoring services or math textbooks recommendations or math courses. We are here to serve. So amosthemathguy@gmail.com or amosthemathguy.com. Take care and have a blessed day.